Perfect. Okay, so I'm going to shift now, and I want to talk about stateful workloads. So just recently, in the past month and a half, we released support for uh, EFS integration with ECS. And what that means is you can now mount, whether you're running on EC2 backed uh, uh, task or a Fargate backed task, um, you can actually mount an EFS volume to your task now. So this was just recently released.
And what is EFS, by the way?
So good question. EFS is our Elastic File Service, and we have a little primer here. File system. I named it wrong. Man, fail. But basically, it is a managed NFS file system. So it's highly available, scalable. You can deploy it in one AZ. You can span multiple availability zones. AZ's availability zone, um, but it's a shared file server file system. So
Yeah, so just like many of our other services, we saw that customers were trying to figure out how do I build a highly available replicated file system, and so we decided, we could solve that problem for so many of our customers. So we built EFS, and EFS has been around now for a long time. It has a terrific track record, and it is super easy to just build and deploy and instantly have a file system available across any and all of your availability zones. And when you then pair that with containers and the desire for stateful workloads, it's a great match because you don't have to think about a availability zone pinning or anything like that. It's a storage mechanism that's available across all your availability zones, and it scales to exactly the size that you need. You can have just a very small amount of data, or you can then, just start dumping tons and tons of data into it, and it grows right along with you.
yep, exactly. Yeah, that's a really good point. You don't have to define your space up front. You don't have to define, I need n amount of megabytes, gigabytes, terabytes. It's just it will scale to meet your demand.
Exactly. Yeah. In the chat, Cloud 77046 mentions EFS is bound to the region, though, unless you snapshot over to a different region. And yeah, absolutely. We build boundaries, by the region. That way we can, help ensure availability and have that, strong uh, isolation boundary. So to me, that's a good design feature because then, I can have my data in a boundary. I can have my compute in the region, and I can know that those two things are always going to be co-located together. And when I want to go to a different region, I can replicate that data and then have that be available in a second region, bring up all of my workloads there too, and then I can route traffic, based on geolocation or something like that into whatever the closest region happens to be.
Yeah. Yeah, and even regional, depending on the region you're in, there's compliance requirements, So the data that lives in one region you may not want in another region. So that's also another benefit of that intention of keeping your data staying in that region unless you explicitly replicate it out.
Absolutely. He also points out you also pay for what you use instead of what you provision. With EBS as a contrast, you pay for what you provision. So those are all good points.
Very good point.
All right, back to the demo.
Back to the demo. It's okay. We can keep talking too. So um, for the demo, what we're doing is so we're going to deploy a cloud file manager using Fargate. So we're using an open source file manager called Cloud Commander. And this is just a high level overview of what that architecture is going to look like. There will be a load balancer in a public subnet, but our actual service is going to be deployed via Fargate. So I'm not managing any servers, but that's going to live in a private subnet, and that service is going to it's going to mount a volume from EFS. So what I did was while we were talking, I actually ran a CDK deploy just so we could have it up and running. And what I want to show you is some of the code so we can see what we're doing. So a lot of this stuff now, because this is an example of a service where we didn't have the support in CloudFormation, if I recall. So what we're doing is we're actually building all of the resources that we have available using the CDK. So we built the security groups to connect the EFS file systems to our service, as well as created the EFS file system itself. So this is an example of kind of working within those, if something's not available in CloudFormation, we built everything else, and I'm actually going to now deploy the service itself. We're going to do that using the AWS CLI. So we deployed our load balancer, all of our resources we need to have EFS ready to go. Now we're going to export some outputs from our CloudFormation template. So we're going to let that happen. And then, so we have a task definition. So if we look at the task definition, and we talked about this earlier in the week, a task definition is a way to define your how you want your task to run. So what container or containers do you want to run as a part of this instantiation of a task? What type of resource allocation do you want to grant to those different containers? What container images do you want to point to? And many more things. So that's how you define your task in the Kubernetes world. You may refer to it as a pod, but essentially that's how you're deploying that spec. And I will actually let's take a look at the task definition. I'll scroll down. So when we were deploying our services using CDK, I didn't have to create a task definition. Through JSON, I was able to do this through the CDK construct libraries to build this task definition for me. But so this is an example of a task definition, and specifically a couple things I'm going to point out. One is here is our container definition, and in our container definition, I'm saying I want to run this container on port 8000. Also, I want to mount it to on the container. It's going to be in the mount FS directory. And where am I mounting that from? Down here, I define my volumes. So I have my file system ID, and where in that file system do I want to mount to? And we can get more granular here. There's access points that we can use, so we can get even more granular with access. This is a very, very generic access pattern here, but you can get very...
We're trying to keep it simple.
Yeah, exactly. But you can get as deep as you need to be as granular as you want. So now I'm just gonna do some command line logic to replace some of these values in the task definition. So I just generated my new task definition, and now I want to deploy the service. But actually, we're going to do this. We're going to create the task definition in ECS first. So I did that using the AWS CLI. I did a register task definition call. I said, here's my task definition file. And then I'm actually exporting the ARN, so the response output. I want to take that ARN because I'm going to need that when I deploy the actual service. So now we're going to create the service. So let's do that. And that's it. So it's pretty tough because it's so large on the screen here. But what I did was I issued a create service command through the AWS CLI, define my cluster, task definition, the load balancer that I want this service to point to, how many I want running, what platform version, launch type, etc. And by the way, as you can see, I did quite a few things to get this deployed. Just another kind of talking point to CDK, how it takes a lot of these nuances and handles them for me.
Awesome.
So, okay, so we've deployed the
Cool.
service. Are there any questions or anything in the chat that we should
Not
address?
not so far.
Perfect.
So I would point out one more time, just to recap, though, that this particular service that we deployed isn't even a service that we wrote. This is something that's just an open source project that we're pulling down the container from Docker Hub and pushing it up and building a service around it. So I think that's cool.
Yeah, good point.
I don't know how to say this username. Denny111 says CDK is bananas. So another CDK fan. I think this thing is catching on fast. It's pretty amazing.
Yeah, and I mean, there's, it's one of the beauties of open source is the amount of contributions that start to, as something gains steam, the contributions that come in, but then the projects that people create um, on top of CDK. So an example is the CDK patterns. There's now people who are writing, reusable CDK patterns. Like I get there's quite a few of them, but I see them on Twitter as new patterns are released, and it's cool to see what the community's doing to make it even easier to deploy with CDK.
So recapping, we launched a service. We attached it to an EFS volume, and right now we're basically just waiting for the load balancer to come up and go healthy. So that should happen pretty quick.
Oh yeah, that already happened. We were just talking.
Oh, perfect.
we were just talking. So, yep. And so we've deployed our Cloud File Manager with our mounted volume, which is pointing to an EFS mount point. And what I'm going to do is, for funsies, I'm going to create a directory, EFS demo. And again, so this is a file manager. I mean, it's obviously pretty straightforward, pretty simple, but obviously the benefit of, generally when we run containers, this is another one of those kind of religious arguments, but generally I would say the majority of containers aren't stateful. They're stateless, and the idea is they go away, come back, and they're constantly churning and burning. But there are use cases where people are deploying stateful containers. So the data needs to persist after the life of that container runs.
Exactly.
So I'm just going to add some more EFS2. So you can see I've just created directories here. Again, this is a cool project. And actually, I think it was Martin Beebe. I think he works for AWS, and he wrote a blog on the support. So I lifted this tool from him because I was like, man, this is such a great way to demo this service. So, all right, so we have our file manager. It looks great. I see my files here, super awesome. But now what we need to do is we need to confirm that this data will persist after this container dies. So what I'm going to do is, okay, I'm in the service here. I am going to, what happened here? Kill this task. For some reason, it's just, okay, I'm going to stop it here. And what'll happen is now this is going to go away eventually here. So I'm going to refresh, and at some point, my service is gone. The load balancer is no longer going to be able to serve traffic to my container running, which is mounted to an EFS volume. And there it is. Uh-oh, where's my data? Oh no. So as you can see, where where I'm going with this. Were you going to say something?
So it's just, I mean, simple example, ephemeral container, but the data itself lives past the lifespan of the container. So you can come along and you can replace the container as many times as you want, potentially upgrade the container, pull down the next version when that's available. And you don't have to figure out what do I do with my data? How do I get it into the new container or anything like that? So, and also you don't have to worry about, am I running in the correct availability zone? Can I attach that EBS volume or anything like that. This all just is available as long as you're in the correct account, region, cluster, VPC unit. Like those are all the boundaries that you have to deal with, and those are all some really basic boundaries that I think everyone is totally used to dealing with.
Yeah.
So that's really cool. How are we looking as far as our replacement container coming back up?
Yeah. So here it is. It's in a provisioning state. So the container's on its way up, and what we should see now is once this container is up and running and it starts to serve traffic, um, we should see those files, those directories that I created, they should still exist, because again, it's pointing to
Yeah,
that same backend data store that it's writing data
I
to.
forgot to ask. Sorry, I forgot to ask. Is this a Fargate container?
This is Fargate. Yeah, exactly. And so, typically prior to Fargate, how would we do this, right? We'd have to mount the file system to our EC2 instance, right? And then we'd have to make sure that every time a new instance comes up, it's automatically mounting, and that then we point our container on the EC2 instance to that path on our file system. Whereas with Fargate, you don't have access to the EC2 instance, so you can't do that, right? So this way, we're this enables us to basically not have to do all that stuff to get to this point that we want to get to. We just say, here's our volume, here's our mount path in the container, we're done. And
Yeah, and it also elevates it become that mount point or that volume becomes a first class citizen with our application. So we can sort of tie those two things together and not have to figure out or count on that just already being there and being available to our application.
exactly. And so now my service is up. I've refreshed. You can see here the directories I created. It's all there. EFS demo, and I mean we're good. So what did we do? We deployed a Fargate service that requires a stateful an aspect of stateful backend, and in this case, we're using EFS, which is our managed file system service, to use that place as where we're going to store those files, those objects, and basically we had the container up and running. It mounted to the EFS volume. Container died. New one came up. That data was not lost. The container was able to repoint to that, serve that data just as we would expect. So,
Awesome.
yeah.
All right. Well, we're pretty much at the end of our time, so let's just recap for everyone on the stream. You're at ECS Workshop. We're doing containers from the couch. Going through ECS Workshop today. We're going to wrap up tomorrow with our final day for the week. And we're going to be going over capacity providers tomorrow. And we're going to talk about how you manage scaling, both Fargate tasks and EC2 data plane so that you can, make sure that your cluster is always sized correctly. And we're going to throw in some mix of, mixing together both on-demand priced Fargate tasks as well as some spot priced Fargate tasks, and try and show you how you might be able to save a little bit of money at scale. So come back for that tomorrow. That's probably our most complex topic, so we save that for last. And then for next week, come back when we start going through EKS workshop, and we start talking about similar topics, but around using EKS as your orchestrator instead of ECS. So thanks everyone for coming, and we hope to see you tomorrow.
Awesome. Thanks, everybody.